Two and a Half Admins, episode 47. I'm Joe.
He's Alan.
And I'm Jim.
Don't confuse people. Yes, here we are. So we've got a lot to get into. Let's start with some feedback. And Jay says, I've been catching up on the show and just went through episode 28, featuring the clustered Samba question. I just wanted to push back a little on Jim's expression of mild disdain for Ceph. From scratch, Ceph is a massive pain in the ass to deploy and administer. But if you have the home lab illness that causes you to enjoy running your own infrastructure like I do, Ceph can be a cool way to do clustered storage if you like running Proxmox to run VMs and containers. Ceph is built into Proxmox, and deployment and setup is literally point and click. If you have 3 or more machines, even not particularly powerful ones, provided you have fast networking and a large amount of RAM to support OSDs, Ceph can be a good choice for redundant/durable and even reasonably performant storage for file, block, and object. Documentation on the Proxmox website is super straightforward.
I'm not sure that I would agree with the mild disdain part. Ceph is a perfectly cromulent clustered file system if you need a clustered file system. It's just that most people don't really need a clustered file system. And I do feel like there's an awful lot of things glossed over in Jay's feedback about how easy and, quote, reasonably, unquote, performant his home Ceph cluster is. There's a lot of devils in those details. You know, for one thing, most folks are only going to have gigabit interfaces on these random machines they've got lying around, which means now your storage is on the wrong side of not only one, but several 1 gigabit interfaces. It's a lot of complexity that I'm not really convinced you're getting a return on in terms of reliability and performance and ease of maintenance.
The fact that most of your entire question was, you know, I know it's complicated, but. It's like, okay, so yes, it's hard to set up if you do it yourself, and it's not that hard if you just let Proxmox do it for you. But when it goes wrong and you have to fix it, if you didn't set it up, you don't know how it's set up.
Right.
Yes, it's just a home lab, but, you know, if you have data, you probably like your data and don't want it to go away. And so you really want a system that you at least have some understanding of, so that if something goes wrong, you can try to work on it. So if you want to learn Ceph because you're going to use it in a production deployment someday, then playing with it in your home lab could be interesting.
Absolutely.
But like Jim was saying, if you don't need it, it's a lot of extra headache. And if you're limited to a gigabit interface, that's the speed of one spinning hard drive. You know, maybe for random IO, you can do a bit better than that. But throughput-wise, a gigabit link is only 100 megabytes a second. That's not very fast at all. You can beat that with a single spinning disk. So if you want your VMs to be fast, you probably don't want to have them connected to fast storage over a drinking straw.
It's not just your data you've got to move over that drinking straw either. You know, you're sharing the same transport with your actual storage commands as well as the returns from those commands, you know, the data that you're looking for, the data that you're looking to store.
Right, and all the OSD stuff.
Yeah.
Okay, Josh says, I wanted to share my recent ZFS success story. I use Proxmox in my home lab, and recently my power went out, and my UPS failed to stay up long enough for me to manually shut everything down. That being said, the host wouldn't boot after that. My only solution was to nuke and pave the OS. Luckily, I had all of my storage and QCOW2 files separated from the OS drive. I reinstalled the OS, ran zpool list to see what was available, then zpool import, and everything mounted where it originally was. I had to change some config files, but all of my data was intact, and I was up and running in just over an hour. I was surprised at how easy it was to recover from that. Now to find a more reliable UPS so this doesn't happen again.
Congratulations, and yes, that's an important part of what should be anybody's virtualization strategy. I also have all of my VM data separated from the host operating system, and I basically just don't care about the host operating system. You know, it's a throwaway. I can replace it in 15 minutes tops. I'm not sure with Proxmox specifically, but in general, you know, one little gotcha is you kind of want to make sure that You've got your VM definitions, however that happens to be set up with your particular stack. On KVM, that's going to be a set of XML files, and you want to make sure that those are on a ZFS data set as well, so that those can also just be imported with your pool and, set in place of where etc libvirt would normally go on your, host operating system. But yeah, everything's just that easy. When all the work happens inside the VMs and you're careful not to get super attached to the host, then you can just blow the host away and replace it anytime you need to. It's nice.
Presumably you two haven't had the power go out on your ZFS pools very often, but is that common for them to survive totally intact then?
I have never heard of a Z pool dying after power outage unless there was some corresponding hardware issue.
ZFS was designed from the beginning specifically to be immune to this.
Right.
So it's doing these transaction groups, and when you go to do the import, it looks through the list of Uber blocks, of which there are 32 if you're using 4K sectors or 128 if you're using the 512 byte. Anyway, it looks through the list and finds the newest one, and then tries to build the block tree off of it. And if the checksums all match, then that one's good, and it imports it, and your pool's back. If it doesn't, it steps back to the one before, which would have been at most 5 seconds earlier, and then is like, oh, this one's fine, I'll import that. So at most, you lost the data that was in the process of being written when the power went out, and you were going to lose that anyway. But because it's copy on write, it makes sure you don't end up with this thing called a shorn write. If you're using a regular overwriting file system, and it's in the middle of writing a file, you're going to have overwritten the first half of that file with the new data, and the second half of that file is still going to be the old version, and it's clobbered, and the metadata doesn't know how big the file should be, and everything goes to shit. But with ZFS, you either have the version before you updated it or the version after, never anything in between. The other thing that I've been able to do with ZFS, which is usually impossible with hardware RAID, is migrate the disks to a different machine that had a different controller card. Mm-hmm. Like I had an Adaptec HBA die, and I needed to move it to a machine with an LSI. And if you have a regular RAID array, some of them are somewhat compatible, or you can maybe reconstruct it and line it all up. But usually it's either crazy data surgery or a bad day. And with ZFS, it's just zpool import. And hey, look, there's all my data. And the fact that ZFS can even do that across different endiannesses. So if you go to import it on a PowerPC machine, it'll be like, oh, all these bytes are backwards, but I'm ZFS, and I know I wrote down with each one which way around it was written, and I can always convert it to the other one. It was one of the original goals of ZFS to be compatible between the SPARC and the x86 machines. Nowadays with ARM being the same as x86, it's not as big a deal, but most other file systems can support both, but can't support going between them. You format it ext2 in big endian or little endian, but you don't try to read it on the opposite. And ZFS can do that too.
Yeah, a lot of this is like if you ever heard database junkies talk about how, MySQL sucks and Postgres is the one you want because MySQL started out targeting performance and they tried to add correctness later, whereas Postgres went the other way around. They said we're going to build the most correct database from the beginning and we'll worry about the performance part later. That's kind of the story when you're talking about ZFS versus ext4 or really any of the other traditional file systems. Any modern file system is journaling, which means that it should survive power outages reasonably well. If it crashes in the middle of a write, then it'll replay the journal to make sure that the file system itself at least is intact. Now, you may still have a file or two that's broken, because like Alan said, if you're halfway through the process of overwriting a file in place, well, it's going to be halfway bunged up when you reboot no matter what. Again, when you're not talking about a copy on write file system the way that ZFS is. But solving all of these issues, getting the data integrity right, that was the fundamental principle of ZFS.
Okay, Ben says, regarding tracking IPv6 devices, set up an authenticating proxy with Squid and block all other devices from accessing the internet at the router. You'd be tracking the user, not the device. Probably good enough.
Possibly better.
Okay. Some software can't handle an authenticating proxy, but on the plus side, some malware can't either. And if it can't contact its CNC server, that's probably a good thing. Alternatively, and a lot simpler, allow outgoing connections only from addresses in your DHCP range.
I think maybe the right solution is basically install a captive portal at your house with some kind of login system, and then just have it have a really long timeout so you don't have to do it very often. your session is saved and you stay authenticated to the captive portal, but it means that if you pop up on some other device, you just, yes, I'm Jim, this is my internet, I can use it. But anything else is just told to bugger off.
That all sounds great until inevitably you have some kind of device that you really can't reconfigure for anything. You can't make it join a VPN. You can't make it use an authenticating portal. It just has to do its own thing or it won't work at all. And then you decide whether to use that device or not.
Right. You could probably have a whitelist of MAC addresses. That's hopefully not the same device as having the I'm changing my MAC address all the time to hide from you.
Probably.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Alan, you found a post on Brendan Gregg's blog, his talk from the LISA 2021 conference, Computing Performance on the Horizon. I watched this video, this talk of his, and there's a lot going on in it.
Yes. If you're not familiar, Brendan Gregg is the guy who found out that screaming at hard drives makes them slower while working at Sun on the Fishworks, which is a diagnostic tool. Anyway, he's written a lot of books about systems performance. I just got his new book a couple weeks ago. So it's a very big book about systems performance. Anyway, he's written a lot about systems performance, and he does systems performance at Netflix for a living now. But this talk is not from Netflix so much as just his musings on how computing performance is going to change over the next 10 or 20 years and where he sees things going and what some of the problems are.
What's interesting is how many facets there are to system performance. It's basically just everything, isn't it? From CPU, memory.
Well, and just the interconnects that connect your CPU to the memory.
Yeah, it's just every aspect of computing, essentially, that he has to deal with for a living.
Yeah. He starts off with just looking at CPUs. We've not really seen the gigahertz go up, but we've seen the core counts go up.
I predicted that back in the 1990s, and everybody laughed at me, by the way.
Yeah.
What, so were people in the 90s expecting us to get to like 15 gigahertz and ridiculous stuff like that?
Yeah.
I don't think they had a real solid grasp on the numbers, but yeah, all of the technical friends that I had in the 90s just expected clock speeds to keep going up and up.
Maybe it would slow down, but it wouldn't just stop for 20 years.
Yeah. Even in the late 90s, before dual core processors, I said, at some point the clock speeds are going to stop going up. And I expect we're going to start seeing, a lot more multi-processor systems, and the number of processors is going to scale up massively. One day you're going to be looking at, 32 and 64 core systems. And I got laughed at roundly for that. Well, who's laughing now, jerks?
Well, one thing he says is that he predicts that multi-socket machines won't be a thing. It'll just be more cores per socket.
Yeah, almost certainly.
Yeah, like even now, you can get more cores in one socket than you could have gotten with a 4-socket machine a couple of years ago. This other point is that the memory and the interconnects have not kept up. We've seen the number of cores go up by 6x over the last couple of years, but the speed of the interconnect between the CPU and the memory, or the CPUs and each other, has only gone up by 3.2x, meaning that if you have a multi-socket system, you have limited bandwidth to talk to the RAM that's connected to the other CPU. And another point he makes is that the CPU utilization number you see in your operating system is a lie. Most of the time your CPU is busy, in air quotes, is actually stalled waiting on data from memory to be able to do any more work. And if you're talking to memory that's in a dual socket system and you're having to, half that memory is on a different socket and has to go across an interconnect, and your speed limited there, it means more time spent. Your CPU is busy doing work, but actually it's just waiting for the data to get to it so we can actually process it. And if we just keep adding more cores and making things bigger, but not getting the interconnect any faster, then it's just going to get worse. And so sticking to a single socket will probably be better. But we've even seen single socket systems that have a NUMA's type setup where some of the memory is actually further away, not as far away as in a dual or quad socket system, but still where there's a difference with talking to, local RAM versus far RAM.
And I think a lot of people don't realize just how unperformant multi-socket systems really are anyway. NUMA problems are an absolute nightmare, and even with careful tuning, you're usually only going to get about 2/3 the performance out of a dual socket system that you would have expected out of a single socket system with the same number of cores running at the same clock speed and everything else being otherwise the same. If you have the opportunity to spend the same amount of money on, for example, a dual socket EPYC machine with a total of 64 cores, or a single socket EPYC machine with 64 cores, that single socket machine is going to outperform the absolute crap out of the double socket one every single time.
And have, I guess, the same number of PCIe lanes. You're not actually gaining anything by going dual socket.
You can address more RAM going dual socket. So if you absolutely need to address 2 terabytes of RAM, then yeah, you want a dual socket box. But that's literally the advice that I give my larger customers about, when to go dual socket. I'm like, when you need to address more RAM in one machine than you physically can with a single socket board, that's when you go dual socket and not before.
Yeah, because another thing you talked about is because the operating systems and the applications can't really scale to having 64 cores and using them fully. Usually we've built applications that scale horizontally across multiple computers. And so usually you'll get more performance out of 2 32-core machines than you will out of one 64-core machine. And so we're going to probably see more horizontal, but we're also going to see more cores. And he says, at some point, we're going to find a limit, though, where just the contention and the operating systems just won't be able to handle 1,024 cores. And workloads that need that much are going to have to just scale out across machines instead.
One thing that you talked about was how lithography is basically just marketing now.
Jim taught me that when we were talking about the desktop CPU stuff. That many nanometers doesn't actually mean what it used to mean. It's just marketing terms now.
Yeah, and you made some predictions about how that should be counted, at least in the future, but we'll have to see if that actually comes to pass.
Yeah, and another prediction he had is that SMT, the symmetric multi-threading, probably just going to go away. As we get more and more cores and we're reaching the limits of, the operating system scheduler can't deal with that many, it'll make more sense to just have 64 real cores than 32 real ones, each exposing 2 threads.
And there's already, for a lot of workloads, there are advantages to turning off hyperthreading, even when that means you're cutting your total number of CPU threads in half, because you get a lot more predictable scheduling. And in some cases, you're better off with the predictable scheduling and always having an unloaded core to work with than you are with, just kind of stacking everything up to the roof and, hoping hyperthreading will chew through it a little bit quicker.
Right. And because basically hyperthreading is just taking advantage of that stalled time. It's one core, and if it's actually working, the hyperthread is going to take away performance. All the hyperthread's actually allowing you to do is steal back some of the performance that's lost and all the time your CPU spent stalled. So some workloads it's helpful for and some it's not. And as we just get more and more real cores, it won't make sense to have the threads anymore. Because yes, I've definitely seen a machine where I got a lot more performance by disabling the hyperthreads. Plus, we've also seen the hyperthreads cause a lot of security issues, and some operating systems are disabling them by default. And so I don't know that they're long for this world. But then he also talked about new CPUs coming up, as we're seeing ARM taking off, but also we see Amazon, Google, and Microsoft all looking at making their own dedicated ARM chips for the cloud. He also sees AI-directed processor design. If you're Amazon and you can analyze 100,000 of the most popular workloads being run on AWS, you could design the next CPU to be faster at those 100,000 most common workloads.
Hopefully. It's scary, though. You got to be really careful of that, because the thing about AI is you don't know what it's going to do. That's the entire point of AI, is you don't know what it's going to do or why. You just hope it will do the thing that you want it to. There is already some work being done on using AI to optimize CPU design. I can't remember where I saw it. There was an interesting piece about a neural network that was tasked with doing the layout on, I think, a RISC-V CPU. So when you look at the ground floor layout, of the processor on the silicon and where the individual components are placed, humans are going to build everything and basically look like a Roman military fortification, right? You've got, distinct camps and areas with wide avenues between them. It's all laid out very neat and logically. And there's a good reason for that, because, you want to minimize the distance that, any given signal needs to travel in between two places. You don't want things to get bogged down, installed, and, waiting behind something else. But when they trained the neural network and told it, okay, now you do the ground floor design on this new CPU, it came up with this weird shotgun-looking pattern that no human would ever have designed for that, but it outperformed the traditional designs when they actually put it to the test. But I think one of the key things that you're looking at there is, the AI wasn't just told, hey, make me a CPU. It was given one very specific task that humans could then inspect and see, okay, A, what did this thing do? And then, B, test and have a good expectation that they'll be able to uncover all the implications of what the AI did. The more control you give the AI over that process, the more likelihood you're going to discover down the road that, it took some really nasty shortcut that you would not have wanted it to take. But that's what they do. They find shortcuts and they take them.
Yeah, like you're basically, when you give it the list of, here's all the components and you can just decide what order to lay them out in, that's a bit different than it deciding, well, if I just don't connect these two bits, then it'll generate random numbers really quickly. They just won't be very random.
4 is a perfectly cromulent random number. I don't know why you'd ever need a different one.
Yep. But there's some other interesting things in here, looking at like the speed increase we see with DDR5 and kind of projecting that out when, okay, we'll see DDR6 in like 2028 and it'll be 100 gigabytes a second. But also looking back all the way to the year 2000 with DDR memory and realizing that latency is about the same. We've been at 14 to 15 nanoseconds or microseconds or whatever this whole time. And the latency of memory has never got any better. We've increased the throughput by a lot, but the latency for reading one specific thing out of memory has not gotten any better in 20 years. Maybe we need to do something about that.
Latency is usually the harder problem. I mean, you'll notice that the throughput can be massively improved going from, like a consumer SATA SSD to a consumer NVMe drive. But the latency, when you throw it like a 4K random read workload, tends not to change a whole lot.
So we also talked a bit about persistent memory and that becoming possibly a new tier in between RAM and your regular storage, even if that storage is NVMe in the new era. But that it'll only make sense if you can get affordably about 10x the amount of RAM that you can get. And he's already looking at, you can get a 1U Supermicro box single socket that can take 4 terabytes of RAM. So suddenly you need 40 terabytes of persistent memory in order for that to actually be a useful tier in the storage mechanism. But he also talked a bit about hard drives, and with them doing weird things like shingled magnetic recording and so on, we're going to see hard drives get bigger and bigger, but weirder and weirder. And then looking at flash and saying, as we keep going up with these QLC and more levels of cells, we're getting much worse endurance or lifetime, and we're adding more and more wear leveling and logic, which is more things that can go wrong. And that the biggest thing that results in is you're going to get more of these latency outliers where, this disk normally is fast, but when it has to do some wear leveling or something, it's randomly going to stall. So you're going to have this very fast disk that every once in a while it gets really slow for a little bit.
So in other words, it'll behave like a disk.
Yeah. Disks will continue to be terrible forever, I think was his point.
Well, there'll be a link to Brendan's website where he's got the YouTube video embedded and the slides as well. 113 slides, and they're all pretty packed. So it's well worth checking out. Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. Let's do some free consulting then, but first, thank you everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. So Tulio writes to us, I always hear you bringing great insights on disk arrays, disk file systems, ZFS, and the need for proper backups and stuff. However, I don't remember you ever discussing magnetic tapes. After much consideration on what strategy I would adopt to have a good backup for my Synology ButterFS file server, and inspired by the autoloaders we have at the office, I went to LTO 8 and I'm pretty happy with the results. Media cartridges are somewhat cheap, about £80 including VAT for 12 terabytes, long-lasting, trustworthy, allow me to produce multiple copies of my data, and it's pretty fast. You can write around 300 megabytes per second if you're using 10 gigabit Ethernet. I'm running Bacula on Ubuntu and getting solid results. Despite the fact that LTO 8 tape drives aren't particularly cheap, about £1,800 plus VAT, which is 20% here, I think the overall investment seems to pay back if you have a considerable amount of data to back up. I'd appreciate hearing your thoughts on magnetic tapes, LTO technology, autoloaders, and such kind of offline backup technology.
I think it boils down to if you enjoy your tape backup strategy, then good for you. It's not something that I would personally want. As you mentioned, the tape drives are quite expensive. But I think, the biggest thing that you didn't really go into there is that a tape drive is by definition a sequential access system, not random access. I got real tired of sequential access reading and writing, back with Philips cassette tapes on Trash 80s back in the early 1980s. I don't really want to return to it. I'm also not particularly impressed by the 300 megabytes per second. Yeah, if everything holds together well, you can write to about 300 megabytes per second. It's a little faster than a single Rust drive with a similar workload, and a single Rust drive is not really an impressive performance metric for me these days. There's also the problem that asynchronous incremental replication onto a tape device is a nightmare because, you do a full and then you do a bunch of incrementals based on that full, and then eventually you rebase on another full. So, you're constantly producing fulls and incrementals. And if you ever have to restore from it and you're doing incrementals, you've got to start from the full and you've got to patch it over and over again with each incremental that you've done since that full up to the point that you want to restore from. It's slow. It's a pain in the butt. You're not sure of what you got until you get there because it is sequential and cold and, offline, as you mentioned. And as Alan and I keep harping on, if you don't test your backups, you aren't backing up. And I don't have the time to sit around and faff about with a bunch of tapes and test them and do basically full restores. You kind of have to really be sure what's going on with them. It's a lot of time and a lot of effort that I don't have any interest in. I greatly prefer what I'm already doing with ZFS replication onto other hard drives. That also addresses the issue, what do you do when you have more than 12 terabytes worth of data to back up and you got a 12 terabyte tape? Yes, there's ways of splitting up your backup between multiple tapes and sitting there and swapping tapes in and out like it's the 1990s and, you've got a 3.5-inch floppy disk, but again, not what I want to be doing with my time personally. I just want to do my, hot asynchronous incremental replication between ZFS on random access devices and literally be able to just look at the list of snapshots, on each of those devices and say, yep, replication's good. I know all that data's fine. Yep, I'm scrubbing regularly, automatically. I've got the output right there in my Zupool status. I know that's fine. I know it's good. I can move on with my life.
Yeah, like I have a friend who has tape drives, like he inherited them or something and likes to play with them. And so he does his backups using Bacula, but on FreeBSD. He buffers to disk first and reorganizes it all and then sends it out to the tapes. But for almost the same amount of money, you can buy a machine and a bunch of 12 terabyte hard drives and just use ZFS replication and, like Jim said, be able to do a scrub and so on. I know a company had made a product that used ZFS on tape so you could actually scrub the tape and so on. I don't know how they did it so that because you can't randomly read from a tape to do a scrub. It will take millennia if you're not reading that tape sequentially.
And what about this idea of long-lasting and trustworthy?
If you're maintaining a tape in ideal conditions, like if you're sending your tapes off to Iron Mountain or whatever for storage, a tape that is in good condition to start with when you recorded on it can hold that recording pretty well for, decades in, again, managed predictable storage environments like you'd get at like an Iron Mountain facility. You are not guaranteed to get the same thing, just like, sticking it in your spare bedroom at home when the temps might reach, 80s in the summer and might, be down in the 60s or maybe lower in the winter. You don't have humidity control. You don't know what's going to go on with it. The other thing about that we haven't touched on yet is that, that's talking about the lifespan of a tape that you wrote to once and then you just want to keep that offline, ready to restore whenever. Your lifespan for tapes that you are actually writing to actively is considerably lower. And if you're doing, like a daily backup onto a tape, it will probably be no longer useful within a year. As I have seen many small businesses find out the hard way because, they just had the tape and they put the tape in every day and they hit the button to do the backup and they put the tape in the next day and the secretary takes the tape home at night and yada, yada, yada. And, by the time they call you in as a new consultant because a hard drive died, they need to restore from that tape. You see that tape and you just immediately have this sinking, I know that thing is not going to mount and catalog properly. It never freaking does. It never does.
Yeah, it sounds like this is technology of yore, and it was very good at the time, but we've got better stuff now.
If you specifically want long-term cold storage, LTO tape is probably not a bad way to go. That's just not something that most of the people that are looking to back up their systems are really looking for or how they're trying to do it. I would be especially concerned about the longevity issue I mentioned, with the total tape rights that you have available. Because that money that you thought you saved only spending 80 pounds, on a 12 terabyte tape, it goes away really quickly when you realize that you've got less than a tenth the endurance that a hard drive of the same size would have, in addition to all the other, problems that we've outlined already with going with sequential mechanisms instead of random access and yada, yada, yada.
Right. Well, we'd better get out of here then. Remember, show@2.5admins.com for your feedback and questions. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.